रख ले, मैं अपने सहरा के जर्रे जर्रे को खुद चमकना सिखा रहा हूं। जो हवा कभी थक कर रुक सी गई थी, आज उसे फिर चलाना सिखा रहा। रोशनी का मोहताज हूं न साये का तालिब, मैं तो सहरा में भी मोती सजा रहा हूं। Respected chief guest of honor, distinguished resource person, executive committee members, dear colleagues and friends, Assalamu alaikum wa rahmatullahi wa barakatuhu. Before we will start this today's one-day workshop, I'll request our chairman, sir, to kindly felicitate our chief guest with a bouquet. This gathering will look lively if you will put your hands together, please. I request Chairman Sir to felicitate guest of honor, Engineer Akib Sultana Wahida Deva ma'am. Thank you very much. These lines reflect a timeless truth. Real shine comes not from the consuming more, but from using wisely what. On Energy Conservation Day, the wisdom has never been more urgent and more global. Across the world, nations, industries, and communities are adopting innovative approaches to energy conservation that are transforming how we live, vehicle electrification and energy recovery systems, behavior insights and demands, energy efficient standards and industrial appliances, solar rooftop initiatives, awareness campaigning and community programs like this. In this global scenario, where nation innovatives and communities become co-creators of energy solutions, that our seminar finds highest relevance. We are honored to be guided this mission by the leaders whose experience spans policy implementation and technological insight. Before we will start the technical session of this event, I'll request our chairman to have a few words with you.
Very good morning. Assalamu alaikum wa rahmatullahi wa barakatuh. Respected worthy dignitaries, especially the chief guest of the occasion, Dr. Shadiqa Chaudhary Saab, highly thankful on the behalf of the Institution of Engineers that in this winter, being the secretariat outside your job, but you came here. Then our madam, she's also the fellow of the Institution of Engineers, Engineer M. Akiba Sultan Wahideva. She has always nurtured this institution. And then the respected executive committee members, the dignitaries, engineers, and the industrial sponsor, which has rather helped us in this, also conducting this seminar, that is Alba. So I feel it privilege and honor on the behalf of whole Institution of Engineers and Executive of J&K State Center to welcome you with my open heart. Thank you. Actually, the writing is on the wall. National Energy Conservation Day. That means save energy, sustain the future. Right? From the very basic science laws, the laws of energy conservation, it was taught to us in the middle classes, in the higher classes, that energy can be neither created nor destroyed, but only can be changed from one form to another form. And that role technocrats have. They have to make the efficient converters. that will minimize, because energy means life. Just for a moment think there is no electricity and there is no heating arrangement, nobody will be comfortable in the hall, and nobody will have the accessibility to reach here if the vehicles don't have energy. If we don't have energy, we are presently wearing in the winter the such high dresses simply to save energy. That means we are going today to celebrate the day of our life. That means if we are saving energy, we are saving life. And now, what is the role of technocrats, the engineers, and the academicians, research people? That is simply to make more efficient energy converters. इलेक्ट्रिकल की जहाँ तक बात होती है, मैडम तो आज खुद बताएंगे अपनी तकरीर में कि इन्होंने कितनी एफिशिएंसी इंप्रूव की है, बिकॉज व्हेन समथिंग इज बीइंग सोल्ड इट इज बीइंग वैल्यूड. आजकल एनर्जी कंजर्वेशन का कंसेप्ट तो यही है कि सुबह से शाम तक हम एनर्जी को कंजर्व करें. कहाँ 10 बल्ब 12 हीटर, आज मीटर की वजह से लोग कह रहे हैं कि एक ही बल्ब चल रहा है कि नहीं, दे कंजर्व, दे नेचुरली गो फॉर द कंजर्वेशन, एंड दैट इज वेरी इंपॉर्टेंट. और अगर हम इस कंजर्वेशन और रिन्यूएबल की तरफ नहीं जाएंगे, ग्रीन टेक्नोलॉजीज की तरफ नहीं जाएंगे, व्हाट विल हैपन, द कार्बन विल एनगल्फ अस. आजकल आपको कश्मीर का भी लग रहा है कि आपने फॉग और मिस्ट देखी. रीजन इज आर वी आर फॉलोइंग द कोल, अदर सोर्सेज ऑफ एनर्जी. वी हैव टू लीव देम, वी हैव टू जस्ट गो फॉर द रिन्यूएबल. जैसे आजकल स्लोगन दिया जा रहा है सोलर एनर्जी द फ्यूचर, उसकी तरफ जा रहा है. कुदरत ने जो ऊपर बनाया है उसी को हार्नेस करके एक अगर हम उनकी तरफ जाएंगे और कंजर्व करेंगे, प्रिजर्व करेंगे अपनी एनर्जी को, अल्टीमेटली वी विल सेव द लाइफ. So everybody, it should have been a house full. I am really ashamed on the behalf of engineering community. Most of the colleges are on the holiday because of the winter vacations, but there should have been the responsibility as a citizen. मुझे लग रहा है एक स्लोगन जो इम्प्लीमेंट करने के बाद जब आप टेक्निकल प्रेजेंटेशन देखोगे वो यही है कि एक सादा लाइफ, सिंपल लिविंग, हाई थिंकिंग कैन लीड अस टू द सक्सेस. दैट हम इस प्लेनेट को बचा सकते हैं फ्रॉम द टर्माइल, फ्रॉम द जो इसकी डेथ आने वाली है बिकॉज ऑफ द कार्बन प्रिंट्स. उनको अवॉइड करना है. कार पुलिंग, स्विच ऑफ लाइट, दीज आर ऑल एथिक्स, मॉरल्स taught from the basic education by our parents, by our teachers, but we are not implementing it. Then comes the other ideas which are the onus lies on engineers, the institutes, especially the policy makers and the implementation. जैसे हमारी सेक्रेटरी साहब यहाँ है कि हमें उन चीज़ों को, उस रिसर्च को हमें एनकरेज करना चाहिए कि जिसकी वजह से ज़्यादा अच्छी टेक्नोलॉजी का एक फुकदान हो जाए, इम्प्लीमेंट हो जाए, और जिससे हमें रादर एक बराबर एक ग्रीन टेक्नोलॉजी की तरफ रुख मुड़ना पड़े. मैं आज सेक्रेटरी साहब से भी यही तवक्का करूंगा कि इंस्टीट्यूशन ऑफ इंजीनियर्स के साथ कोलैबोरेशन करके जो भी स्टूडेंट यहाँ है, इंस्टीट्यूट्स में है, हम सारे मिलके उनको उनका एक पीछे बैकअप करके ताकि वो ऐसी इनोवेशन करे जो हमारे क्लाइमेट और हमारे रीजन के मुताबिक हुई. आई अगेन wholeheartedly welcome all of you, and now the technical session will start, and I request everybody to be brief, exactly to the point, to save the time, to save the energy. Thank you. God bless you.
Thank you very much, sir. So, without wasting any more moment, I'll request our first Adil Hassan Sahab, working in JKPDD, to present his presentation. Please. Yes. It's not visible. Visibility शायद. Visibility. Visibility क्या है? इससे शायद visibility. अच्छा.
Very good morning to all of you, exalted dignitaries present over here, teachers and academicians, research scholars and engineers. I feel honored to be here among you people today to just spend some time reiterating our commitment towards energy conservation and renewable modes of energy adoption.
What we have come to
project of wind energy was launched there, but that's still stalled. Issues are land transfer issues are administrative issues, piling up of files, and constraints in ease of doing business. So this is for policymakers to see. New energy security challenge, we are going to face it, and we are going to struggle with on national level also, and we are chalking out future strategies, and that's in running process. But what we have in our hands is policy making. Wherever our policymakers go, and as engineers, we need to go for efficient implementation. Modernization of infrastructure is a very important key. So, but besides going for expansion of resources, besides going for utilization of resources, we need to put a cap on decarbonization cost. So actually, wherever in engineering, I was taught a subject by respected Ajaz Saab. Ajaz Saab is here, professor in IIT Srinagar. At that time, he was HOD there. So optimization techniques was one of our subject. Optimization arises when we are given a choice between cost and innovation. So at some point of time, you have to balance and to take leverage of the innovation, but keep the costs at optimal levels. So decarbonization cost is very important. It has very huge impact on financial part of this innovation and balancing of resources. So government investment and greenflation is one of the important factors. At bureaucratic level, greenflation, this is actually, I'm very sorry to say that most people take it otherwise. In our solar rooftop scheme, most people are not convinced only because they think capitalists are being, they are being favored. So actually the problem is we have private players over here. We have 100% FDI policy in India as of now. Most of the times we have private players, 100% of the cases as we are in Valley. The vendors come from private players, so they are getting benefit. But actually the lack of awareness is there among public. People normally go for easy payments, monthly payments of 3,000 rupees or 3,500 rupees, rather than going for 1.5 lakhs or 1 lakh. And there is one more issue that may be looked into. I don't know the possibilities at policymakers level, how to go for and how to get rid of these insecurities among public. There is high upfront cost in solar rooftop scheme. People are not getting enough convinced that they will go for 35,000 rupees down payment or something like that. Whatever the cost is, there is huge investment. They seem that it is huge investment at the same time. If we go for AMI and bank, without no doubt there is policy of AMIs in this, but huge upfront cost is there. So we have greater energy price volatility. We have crude oil crisis. That's there to see for all. We know because of rising global tensions, crude oil has become the key factor in making alliances, going with this fellow or that fellow, be it Russia or United States. So I'm not here to discuss geopolitics, but this is a factor which makes us to think once more for reviving the commitment towards energy conservation. So let's go forward. This is installed generation capacity source wise. So this is the pure data from CEA and non-fossil and fossil fuel.
Is connected.
So this is actually the last thing that I would want to discuss with you. Renewable adoption, interlinking factors that explain the recently happened coal crisis. It's not so far. Just 2 years or 3 years ago it happened. Fuel dependency for power in India is quite alarming. And disproportionate share of generation from older inefficient plants, where we have huge capital costs. So as of now, our plants are running at very low efficiency in J&K. Discom loss in electricity sector, there is important point to cherish that we have made ample and significant improvement in our reduction in losses. So LT cabling is there. Smart meters, lakhs of smart meters have put in. So there are no billing issues as of now, where our smart meters are being deployed for measurement purposes. So globally, nationally, 23% to 17% Discom losses have been achieved. And then there is sustainable development we have to think of for future generations. Strategic energy transition is a way forward. So one important thing I got in poster, this Institution of Engineers poster, is low carbon sustainable development. So the crux is the same. Wind power, we have least wind power potential here, untapped wind power. 4600 are the figures. I don't know whether JKDA people are there. They have shared an energy policy, wind power energy policy, in draft wind power energy policy in 2023, and yet there has not been any progress in that. So wind power, we are not going to tap very soon. But among solar, there are statistics 637 gigawatts can be captured if 280 million people in India go for solar rooftopping. And that's equivalent to 1/3 of our consumption, residential consumption, nationally. That's a huge figure. So carbon sustainable development already comes in place when you go for energy, this renewable energy adoption. So these are the ambitious targets: 500 gigawatts non-fossil fuel capacity by 2030. So there are two targets actually that drive this whole scheme of things. One is net zero emission by 2070, that is a bit too far. And one is close to us, that is 2030. And we have been able to achieve 132 gigawatts out of this 500 in as we sit in 2025. So we have reduced carbon intensity of.
This is already achieved. 5 years behind.
Yes.
This 50% is already achieved.
This is achieved. We are ahead of it in solar. That is why we have been able to replace Japan. It was first. It was on. Now India is on third number. Transport section decarbonization is one of the important things. Normally, when we go to other states, there's a huge flow of public transport. But in Kashmir, 15 साल से पहले यहाँ पे एक बंदा एक गाड़ी में जाएगा. If we have 4 people in our house residing in at our place, we have 4 cars. So this is the first place जहाँ पे apart from कि यहाँ पे उतना डेवलपमेंट नहीं था तब, लेकिन सबसे पहले जस्ट लाइक बेंगलुरु या कर्नाटका में बाकी जगह, पुणे या बाकी जगहों पे, यहाँ पे पहले ये हुआ था कि अपनी गाड़ी में जाना. सो अभी अगर हम देखेंगे जब कभी कोई प्रॉब्लम हो जाती है तो पेट्रोल इश्यूज हो जाते हैं या कुछ, तो सबसे पहला इफेक्ट होता है ट्रांसपोर्ट. एंड ग्रेटेस्ट एमिशन जो होता है हमारा CO2 का, दैट कम्स फ्रॉम, बिकॉज वी डोंट हैव इंडस्ट्रियल यूनिट्स एज मच एज जो बाकी जगहों पे हैं. सो increased ethanol blending in petrol, shifting freight and passengers to public transport. So then there is policies and infrastructure. In load forecasting, coming from electrical background, there is a point that nowadays we are going for SCADA and PLCC. So we are giving real-time data from grids to our control center so that we can achieve load forecasting. It has an impact on power purchase of the state. It has an impact on efficiency. It has an impact on reliability as well. So modernization of equipments is very necessary. Modernization of infrastructure is very necessary. So nowadays we have predictive adaptive algorithms. We run the algorithm and see after 1 hour or after 2 hours what will be the demand, given the set of defined parameters. So this is the progress and impact of already carbon emission factor of grid electricity, including RE, TCO2 by MWH per MWH. So potential solutions in brief, if I'm not consuming more time, solar energy for power generation, वो तो हो ही रहा है, wind में भी हो जाएगा. So power generation underdeveloped and underappreciated. We need to put more efforts. We need to see क्या चीज़ लोगों को convince नहीं कर पा रही है, why they are not going for the solar adoption techniques. Independent fuels, low greenhouse emissions. Perspective, solar photovoltaic and wind are most sustainable. Now the key message to deliver are economic. Future energy crisis can threaten the long-term viability and hinder development. This needs no explanation. Development and social energy availability a must for sustainable growth. Demand continuously increasing. And most important thing that I missed so far is behavioral changes. So nowadays we are seeing government is going to put a cap on AC temperatures. Actually, what that means is we have to change our behavior. So behavior and moral science, it deals with moral science. It has nothing to do with technicalities. So technical solutions include policy decisions, energy transitions, ease of doing business, technological innovation, development and adoption, and so on and so forth. So call for action will be planning at policymakers level, dependency and efficiency. Stories, no more work, we should prefer actions. Need to optimize, this is the punchline. Need to optimize and fix this crisis or they are going to fix us once for all. Thank you so much.
थैंक यू आदिल हसन साहब। बहुत कारामंद बातें, नेट ज़ीरो की बात हुई, बिहेवियर। देखिए, ये हर एक जगह का दस्तूर है कि जब भी कोई नई चीज़ आती है, चाहे पॉजिटिव या नेगेटिव, तो लोगों का रुझान ये होता है अथ के फ़ायदे यमन, यह नो क्या प्रोग्राम यमन। सो बिहेवियर ये, और ये सिर्फ जम्मू कश्मीर तक महदूद नहीं बल्कि पूरे देश, या मैं पूरी दुनिया की बात करूँगा, अडोप्ट करने में लोगों को टाइम लगता है। उसके लिए अवेयरनेस प्रोग्राम्स जैसे हमारा ये आज का प्रोग्राम है, ऐसे प्रोग्रामों से ही लोगों तक बात जाएगी और बेहतर तरीके से लोग इसको अडॉप्ट कर सकते हैं। तो हमारी जो अगली प्रेजेंटेशन है वो हमारे साथ सऊदी अरबिया से जुड़े हैं, रियाद से जनाब तौकीर शफी साहब, हमारे इंस्टीट्यूशन ऑफ इंजीनियर्स के मेंबर भी हैं। तो मैं गुजारिश करूंगा अमान साहब से कि वो उनको कनेक्ट करें।
Assalamu alaikum. Good morning, everyone. Can you hear me?
वालेकुम सलाम। यस तौकीर साहब, यू आर ऑनलाइन एंड टोटली विजिबल। आप जस्ट स्लाइड शो को एनेबल कर लीजिए पीपीटी में ताकि हमें फुल स्क्रीन नजर आ जाए।
Definitely. Just give me a moment, please. Actually, I'm using, मुझे 2-3 स्क्रीन यूज कर रहा हूँ, so I'm just उसको मैं ट्राई तो कर रहा हूँ। लेट मी रीशेयर, मैं रीशेयर करता हूँ। जस्ट गिव मी अ मोमेंट, मैं रीशेयर करता हूँ अपना स्क्रीन। सॉरी। आप बताइएगा जब आपको मेरा स्क्रीन नजर आए, व्हेन यू कैन सी माय स्क्रीन फुल। हेलो,
अभी विजिबल है तौकीर साहब? अभी विजिबल था, इससे पहले ठीक था वैसे।
ओके, it's visible now, I believe.
It's visible, yes. Perfect.
Yeah, great. First of all, good morning. Assalamu alaikum to everyone. Shahid Chaudhry Saab, and all the dignitaries that are present here, and very warm welcome to all my fellow engineers, my seniors, my subordinates, my colleagues, my friends, and everyone who is watching online. So I'm Takir, as you already know. I have been working for some mega projects in KSA, and when it comes to energy conservation strategies, so this is something which we are really focusing all over the world. And I wanted to present this presentation to get my colleagues in Kashmir, in other parts of India, to have an overview of what mountainous mega project looks like. It's a case study of a Neom Trojena KSA, in which I was designing the mobility structures and the rockfall shelters. So this is something I would really like to all of you to have a look at. I won't take much time this time. Last time I took some more minutes, but I will try to keep it as specific and brief as I can. And whenever if you have any questions, just have it with you. I will definitely try to answer each questions in the comments or anywhere. So my agenda today is it's a case study of Trojena that you must be all aware of, as we are all engineers, and as a structures and civil engineer, energy conservation and sustainability is one of the basic goals of all over the world. So just for a quick agenda look, so it will be more focused on mobility infrastructures, with roads and bridges, tunnels, and rockfall shelters. So, if you see, this is a quite comparatively, it's something which we see in our Jammu and Kashmir, the mountains in Jammu and Kashmir. It's quite visible. And the left hand of the screen, you can see the picture of that lake and the mountainous region all surrounded by it. So if we go ahead, what the energy consumption in mountain infrastructures is often significantly higher due to flat terrain, as we all already know about it. So we do deep excavation. We have additional needs such as deep excavation, slope stabilizations, different protection from rockfalls. We can see on our Jammu National Highway just a few months back, we had a prolonged delay in it, which costed the government of Jammu and Kashmir as well and the other stakeholders a lot of economically as well. So we have a different cold weather constructions techniques, longer hauling routes, and tunnel and ventilation and lighting. So, as we know that Trojena is becoming a world-class tourism and residential destination, so the mobility infrastructure becomes critical. But I wanted this to have a comparatively study with regards to Jammu and Kashmir mountains. So, while we talk about the mountain mobility infrastructure, we have four main issues that are the steep and variable terrain, which require a lot of earthwork quantities, and the energy used in the excavation, hauling, and slope stabilization is huge. We have been all through it. We have all seen those mountains. We have gone through them. Then the second thing is the rockfall hazards, and we have a lot of ridge lines which are prone to. We have avalanche zones. We have rockfalls, boulders, landslides, and debris flows. So, other the thing is the weather and climate conditions which we currently are facing in Srinagar and Jammu and Kashmir all over. Like we have an increased energy demand for heating during construction. So I won't touch base that because my colleague engineer Adil Saab has already gone through that. And the second one is icy roads requiring energy intensive maintenance. And the main thing here, which I want to see, like give people an idea, is a durability assessment. That is the material performance variations and specifications which we have been using all over J&K. So next, in mountainous regions, our is achieved through main three, that is the embodied energy, operational, and recovery energy. So when we say about embodied energy, so it's mostly in the material production, transportation, and construction, and operational is lighting, ventilation, heating, and maintenance during the service life. So, and the recovery, of course, we know it is the optimization through maintenance planning and life cycle assessments. So, first thing, the alignment optimization. So we must be very well aware of our alignment optimization that has been gone through from Ramban to Banial, and before that in Udapur sector as well. So this is something which we have to focus on as we are trying to be developed, getting more development in our hands. We have to keep in mind the alignment optimization. So it should uh, be more of a digital terrain modeling and leader enabled topographic surveys, which would be allowed for designers to use to minimize the cut and fill and reduce tunnel lengths, avoid unstable geological zones, shorten bridge spans, and reduce the number of rockfall shelters. So this all reduces the heavy equipment operation time and lowers diesel consumption, which eventually is your energy conservation. And this is not just a small thing like for the start, but it is something which we see as a long-term cost optimization as well. Second thing is material optimization. So we can have high strength steel enabling slimmer profiles and precast deck and girder systems, which reduce on-site energy, and the material as GGBS concrete for reducing embodied CO2. So with this, we will have lighter structural systems with less foundation energies. And the fourth one is the low energy retaining structures. As we live in mountains and we have a lot of retaining structures, so definitely we'll try to go for reinforced soil walls, soil nailing system, precast modular blocks. So this site machinery, as an estimate, has brought an energy saving by up to 40%. And if we move on to the next, that is the tunnels. So for the tunnels, we have seen a lot of tunnels. Mode, we have seen a lot of tunnels that have been constructed, are in construction, and have been open to public now near Sonmark as well. I just been there some 3 months back, and it's a great work done by our team there. So tunnel excavation optimization, as we see, is one of the key factors here, because blast optimization modeling we can do energy efficient drill and blast patterns. We can reuse the main here of the energy conversation, if we see, is the reuse of the excavated materials in the nearby fields. So we have a lot of fill quantities to be fills to be done, so we can reuse that excavated materials. And for the operational energy, we can use energy like a ventilation, lighting, and fire safety system designed to reduce the energies, including ventilation fans using VFDs, insulation for reducing heat losses, and solar powered emergency systems. Moving on, then the Rockford shutters. I think I will move this, because at the end we will always again go for that. So once this is a case study which I've done for the Neom Trojena for the mobility structures, which has led to reduced earthwork, which has led to lower excavation fuel use. For the Rockford shelters, we have used precast roof panels, hybrid steel concrete canopy system, and solar PV integration potential. And for tunnel, we have been using LED lighting, smart sensors, and VFD fans. And for the stabilization, we have been using advanced geotech modeling to minimize the number of slope anchors and catch fences. So, a quick look on a comparative perspective. Where, while I speak about the Neom Trojena itself, so the Himalayan mountains, as we already know of Jammu and Kashmir, are one of the most complex mobility engineering challenges in the world, which are in comparable, which are incomparable in severity to the same Neom Trojena what I have seen here. So both of them consist of very steep, unstable slopes, deep fjords, seismic faults, and extremely harsh winters, making mobility infrastructure both energy intensive and operationally demanding. So unlike Trojena, which is a planned futuristic development, our J&K includes a legacy infrastructure which is currently undergoing upgrades and is offering valuable insights into energy conservation through modernization. So we already know this. I think I will move this again. So while we say how can we reduce the energy and how can we make it sustainable, if we see the BRO recorded significant diesel savings through lidar-based alignment optimization. We will have a fly-through on the roads of the mountains, so just at the end of my presentation, which you will see how we have minimized the deep cuts, how we have minimized the cuts for the those unstable slopes, how we have reduced hairpin bends where we could, and also the very low excavation volumes, because that's one of the main things when we see in Himalayan terrains in Trojena, the road alignment optimization should be one of the basic criteria for it. Secondly, when we go for the energy tunnel, we have to implement the intelligent blast design to reduce rework and overbreak, and reuse of muck, which we already understand, reuse of muck for approach embankments and avalanche galleries, and LED and VFD controlled jet fans. For the rockfall shutters, uh, we could use snow shedding roofs, we could use dynamic impact resistant barriers, and with evolving designs, newer designs, we can adopt lightweight steel drip structures with composite panels, reducing the embodied energy significantly. So logistics and energy demands in J&K, like construction corridors, as I already mentioned, such as Ramban planning, will demonstrate the challenges. Working with unstable slopes and narrow access routes. So our energy saving logistics could be centralized batching plants to reduce fuel haulage, ropeway material transport in accessible zones, winter shutdown optimization to reduce equipment heating energy, and of course the drone-based surveying and monitoring, reducing fuel for field inspections. Such strategies provide lessons that can be directly adapted to mountainous terrain. So one of the first comparative table, as you see on your screens, If you see the primary geology between the Neom Truchina KSA with the Jammu and Kashmir, so it determines the rockfall behavior and how the shelter should be designed. Slope angles, Neom Trigina has less, our Himalayas is steeper, which influences the stabilization energy demand. The elevation range goes up to 4,000 meters, and it definitely impacts our ventilation and cold weather loads, energy loads. The climatic cycles, we have a long freezing periods, while Trojena has a freeze thaw zones, cold winters, but these drive the main material durability requirements. Rockfall frequency is very high. National Highway 44, as we know, Zojila Sonamak, so it determines the shelter type and barrier energy. Same with the seismicity. If we see the seismic zones, we are the high zone in J&K and a moderate in Saudi Arabia, though there is a fault line where this project is governing right now. So it details our structural detailing and ductility needs. And the last one is the infrastructure type. So different operational energy priorities, as that is a Trojena is a tourist mobility and service corridors, but in J&K, our national highways are our arteries to our cities, and of course the defense roads as a priority. So while we say this, what are the energy conservation strategies applied? So we can adopt as a JK, we can adopt avalanche path alignment logic with high precision DTM and LIDAR. For the tunnel efficiency, we can use Trojana's tunnels and validate long-term savings by LED, VFD fans, solar backups, and these. Then we can use Trojana, we can use lightweight systems which can modernize our J&K routes. We can use drainage-based slope stabilization, which can benefit. We already have that, I believe, in J&K, the drainage-based slope stabilization, and we can have ropeway logistics. This is one of the important energy conservations we can do, having a ropeway logistics, and which can be adopted both for Trojena and J&K. Then rockfall predictions. So we saw that we are using lightweight hybrid shelters here, and we are using RCC avalanche galleries in J&K. So we can have a lower embodied energy design for our J&K as an approach, and for roof systems we can use curved slab, which optimizes the reinforcement. For renewable integration, we can use PV-enabled shelters. I believe I haven't seen really seen in J&K. I may be wrong. And in the barriers, we can use same absorption goals and slope drainages. J&K's is good, but we can use different to enhance it as well. So if you see on the screen, I have put some 4 images, and you can see the deep cuts. You can see a bridge on the two sides. The first image here, let me get it right. If you see here, this is a cross-sectional area with the roads and the utility tunnels pass by, and this is something which makes us energy conservation by limiting cuts and fills, having utility corridors running all over the roads, below the roads. I mean, if you see here the bridges, these are micropile bridges where medium-sized micropiling devices go towards the terrain, they do the micropiling, and then the bridges are built. This is a basic concept for these foundations. And here we can see a tunnel going through towards the road, and here we can see a rockfall shelter built across the road to save the energy dissipations. While we go through it, let me play this. It's just a fly through. Just have a look. So you can see how optimized it is. You can see how optimizedly we have done this. So to avoid the scarring, to achieve a sustainable design, not scarring the mountains. We have seen a lot of mountain scarring all over our highways and roads. So if you see this fly through is just to know how can we be sustainable, avoid deep scarring, and how can we be more efficient with not huge pins, not too much of right of way, and we can still achieve very net desirable energy solutions. As we go through this, you can have a look. Please concentrate on the cuts and fills which are marked here. You must be seeing that you have seen a very limited number of bridges, and that's because we always try to avoid the bridges. It's a construction cost. It's basically the optimization costs we do to reduce energies, because it's not easy to build bridges in mountainous terrains. So you will see a very less number of bridges. It's a long video. I will just skip a bit of part. Yeah. So running through, it's a bit of a more, it as the videos will continue. So as a conclusion, the mobility structures, mountainous environments especially require innovative developments like Neutrogena to have a robust engineering approaches that will balance safety, constructability, energy efficiency to optimize through optimized design, low carbon materials, renewable integrations, and modern rockfall protection technologies where energy consumption can be significantly reduced over construction and lifetime operation costs. And as global mountain infrastructure expands, these energy conscious engineering principles will serve as the blueprint of sustainable, resilient mobility systems. And I believe the most sustainable energy is the energy we do not waste. Thank you so much, and I'm open for any questions.
Thank you very much, Tawkir Shafiji. We'll be having question and answer session in the end of the technical
Sure.
session. I will just you'll be glad to know that now our engineers are also working on GIS platforms to optimize the alignments and identify the catchment areas and minimize the cross drainage systems also using slope stability softwares and other catchment softwares. So we are having next presenter is a gold medalist, MTech in structural engineering, AWE in Public Works Department. I'll request Engineer Malik Mudassir Saab to come on dice and present his presentation. Would be dignitaries, our chief guest
of honor, respected teachers, respected chairman, secretary, my dear colleagues, friends, Assalamu alaikum wa rahmatullahi wa barakatuh, and good morning to all of you. I feel honored to speak in front of you on a topic which is relevant to present as well as concerning our future as well. That is, save the energy, sustain the future. We in Kashmir have a great energy challenge, especially due to the severe winter climatic conditions, with heating being most predominant energy demand. So we have rising fuel costs. Maybe we are depending on the fossil fuel gadgets like appliances or electricity, and there are environmental concerns as well. So it necessitates to shift towards energy efficient buildings and construction practices. Here I will try to explain, and we will study how the energy efficient design starts with the simple building orientation that runs through material choices, construction practices, thermal protection systems, and we can harness solar energy as well. And our approach should be holistic, practical, and Kashmir specific, which every homeowner, we engineers, architects, masons, any stakeholder can adopt to drastically reduce the energy consumption. So my topic is on this National Conservation Energy Day is integrating passive design and good construction practices for energy efficient residential houses, homes in Kashmir. So first of all, we have a challenge in Kashmir. That is, we have long winters. We have long winters where we have freezing temperatures, we have snowfall, we have low winter sun. So we have